Good morning, dear respected professors and my dear classmate. Today I am going to present my topic on software architecture in embedded system, which is a fundamental concept in modern embedded design. As embedded systems become more complex, applications like robotics, automotive systems, and IoT devices and medical equipment, selecting the right software architecture becomes critical for performance, reliability, and real-time execution. So here I am. My name is Naimuddin Khandokar. I'm currently pursuing MSc in Computer Science and Engineering at Kumilla University. This presentation, I will explain the key architectural approaches used in embedded system from both a theoretical and practical perspective. So the presentation is organized into five major parts. The first one is round robin architecture. Second one is function queue scheduling architectures. Third one in real time operating system architectures. Fourth is embedded program modeling in single and multiprocessor system. And finally, the embedded software development process. Each of those architecture plays a unique role depending on the system complexity and real-time requirements. Embedded software architecture refers to structural organization of software components. My bad, sorry. In embedded system, it directly affects the three critical factors like determinism, latency, and resource utilization. In real time, the safety critical systems like autonomous vehicles or medical devices or poor architectural design can lead to system failure. Therefore, choosing the correct architectural is not just a design to choice but the system level to engineering decision. So now let's talk begin with the round robin architecture. This is one of the simplest scheduling techniques used in embedded system. In this architecture, tasks are executed sequentially in the infinite loop. Each task receives equal CPU time and there is no priority management. It's commonly used in a small microcontroller based system where computational complexity is low and the time constraint is not strict. So let's talk about the features of round robin. The main advantages of round robin architecture is its simplicity and low memory overhead. It's very easy to implement and debug, which makes it ideal for beginner level and low cost embedded devices. However, the major limitation is that it is not suitable for real time deadline because critical tasks may get delayed if the loop become long. From an MSc perspective, we can say it lacks deterministic scheduling from time critical operations, and that's why it is not suitable for every single problem. So let's talk about the function queue scheduling architecture, which is more advanced than a simple loop system. In this model, tasks are stored inside a queue and the functions are executed based in a queue on order. The architecture is typically event driven, meaning tasks are targeted by events such as interrupts, sensor input, or use commands. This makes the system more flexible and responsive compared to the traditional round robin methods. So the advance of function queue, the function queue provide better control over task executions and improve responsiveness. It especially useful in reactive embedded system like IoT devices, smart controller where event occurs asynchronously. From the system design perspective, this architecture improves modularity, scalability, and CPU efficiency. So now let's talk about the most important architecture. This is the real-time operating system or RTOS. And RTOS manage multiple tasks using advanced scheduling algorithms such as priority-based primitive scheduling algorithm. Unlike simple architecture, RTOS provides multitasking, process, timing control, inter-process communication, and resource management. This makes essential for critical applications like aerospace, robotics, automotive control system, and industrial automations. So the key features of RTOS is deterministic timing, which means tasks are executed within generated with guaranteed deadlines. It supports priority-based scheduling, task synchronization, and semaphores of mixtures, and high system reliability. From an MSc-level viewpoint, RTOS architecture is designed to handle concurrency, real-time constraint, and fault tolerance efficiency. Now let's talk about the embedded programming modeling. Embedded programming modeling focus on designing the behavioral structure of embedded software before implementation. It includes modeling system structures such as task flow and timing constraint using techniques like finite and state machines, data flows, models, and task graphs. This helps engineers analyze performance, latency, and scheduling feasibility before actual development happens. Now let's talk about single versus multiprocessor system. In single processor system, one CPU executes all tasks sequentially, which makes the design simple but limit performance. In constraint, multiprocessor embedded system use multiple CPUs to execute in task parallelly, significantly improve the performance and throughput. However, multiprocessor system introduce challenges such as synchronization and load balancing and interprocessor communication. So you have to control all the things in multiprocessor management. So, embedded system development process. So the embedded software development process follows a systematic life cycle, starting from the requirement analysis, system design, and coding, testing, and finally develop, deployment, and maintenance. In advanced embedded engineering, this process also includes hardware, software co-design, simulation, and real-time debugging. So, importance of development process. A structural development process ensures system reliability, resource errors, and improve overall product quality. This is especially critical in safety critical systems such as medical devices and autonomous systems where software failure can cause serious consequences. So, in conclusion, a different software architecture are suitable for different embedded system requirements. Round robin is best for simple systems. Function queue is ideal for event-driven system, and RTOS is most suitable for complex real-time applications. Finally, a well-structured development process ensures system success, reliability, and scalability in modern embedded systems. So thank you for the kind attention. I hope the presentation provide a clear and insightful understanding of software architectures in embedded system from both practical and academic perspective. So if there are any comments, please let me know in the comment section. I will try to answer it later. So thank you so much for your kind attention. Assalamu alaikum.